Giancoli 7475. And again, collisions and conservation of momentum, some more work on that. So momentum is conserved in all collisions. Collisions in which kinetic energy is conserved as well are called elastic collisions. So momentum's always conserved. Now, if energy is also conserved, kinetic energy, then it's an elastic collisions. When kinetic energy is not conserved, they are called inelastic, okay? So elastic and inelastic mean kinetic energy is either conserved or not conserved. So they approach, they collide. If elastic, kinetic energy is conserved, and you can see the velocities are constant. If it's inelastic, the velocities are less, okay? And that means obviously some energy is probably lost somewhere. So elastic and inelastic mean kinetic energy conserved or not conserved. In one dimension, two objects collide elastically. We know the masses and the initial speeds. Okay, so you see this here. Since both momentum and kinetic energy are conserved, we can write two equations. This allows us to solve for the two unknown final speeds. So we will talk about how to solve these types of.
Okay, so when we look at elastic collisions, there's two equations that are going to be paramount to make your life much easier. All right, and so what we're looking at is we have one mass, so I'm going to call this mass 1, and this is mass 2, and they're going to collide elastically, all right? And when we look at, so this would be V1, and this would be V2 initially, and then they collide, and after they collide, M1 will have V1 prime, and M2 would have V2 prime after they collide. So let's say we want to find the final velocity of M1. Here's the equation we use. All right. If and V1's initial velocity. Okay. So V1 will always be moving. V2 doesn't have to be in this equation. If V2 isn't moving, then you can eliminate this part because that's 0, that's 0. But if V2 is moving, then you have to include this information to find the final velocities. So that's the big thing, is being able to use these equations appropriately. Okay, and I'm going to give you an example of this. But and I know this is like something that, gosh, this makes it way too difficult. The alternative is to do all kinds of algebra, and this has already been solved for us. So we're going to use these equations. All right, so we'll do an example with this here in a second.
Reaction. So equal masses. Billiard ball A of mass m moving with speed VA collides head-on with ball B of equal mass. What are the speeds of the two balls after the collision? Assuming it is elastic. Assume A, both balls are moving initially, VA and VB, and then we're going to also assume B, ball B is initially at rest, where velocity would be a 0. Okay, and we're going to try to find the speeds of the ball after the collision. Do it now.
Okay, so real quick before we even use the equation, but we'll talk about it. So we got equal masses, example 7.7. Billiard ball A of mass m moves with, I'll draw this on the board. Mass m moves with speed VA. So I got, this is the first one, mass m, traveling VA, is moving with speed VA, collides head-on with ball B of equal mass. So B is here, which has an initial velocity, but it looks like it's standing still, so we'll say it's 0. What are the speeds of the two balls after the collision, assuming it is elastic? All right, so they're going to collide, right? Or even if this has a velocity, we'll just leave it as it having a velocity right now, because I guess part B we want to see if it's 0. So this is what happens, okay? So let's take a look. We want to find V1's final. So let's substitute in. Now it says that all equal masses. So the A and B, so that should be A and B of equal masses. So M1 and M2 are the same. So we'll just call them M. Okay. So let's find V's final velocity. Okay. So M minus M, because the masses are the same, over M plus M times VA, which is the initial velocity of A, plus 2m over m1 plus, so m plus m, times VB, all right? So first off, this is 0 over 2m, that's 0, which means this is 0. So the final velocity of A is going to be equal to 2m over m plus m, so 2m over 2m is 1. 1 times VB is VB. So A's final velocity is going to be equal to B's initial velocity, all right? Then let's look at, for B, V2B is going to be same thing, m minus m over m plus m times VA plus 2m over m plus m, I'm sorry, this should be VA, this should be VB. I guess we're talking about the same thing here, right? And then as I solve, here's what I should see. 0 times VB, VB prime is equal to VA. So we expect the velocities to kind of switch places. Whatever A was going in elastic collision, B will now go. So the velocities kind of switch places. Now let's say VB was not moving and VB was 0. If VB is 0, then VA prime would be 0. So stationary ball hits it, ball starts to move, it'll move with the same velocity that A had. A would then take B's velocity, which would make it stand still, so B would be 0. So these equations, extremely useful.
Next example is a nuclear collision. We got a proton of mass 1.01 U, which is atomic mass units, traveling with the speed of 3.6 times 10 to the 4th meters per second, has an elastic head-on collision with the helium nucleus. And the mass of the helium nucleus is 4 unified atomic mass units. That's initially at rest. What are the velocities of the proton and helium nucleus after the collision? All right. So one unified atomic mass unit is equal to 1.6 times 10 to the negative 27 kilograms, but not important, just so you understand the size, really small. And we're going to assume the collision takes place in nearly empty space, so there's nothing else around. Do it now.
All right, so we've got a proton of mass 1.01, traveling with the speed of 3.60 times 10 to the 4th, has an elastic head-on collision with helium nucleus of 4 atomic mass units, initially at rest. What are the velocities of the proton helium nuclei after the collision? We have the mass of one atomic mass unit is 1 times 7 times 10 to the negative 27. Not really that important. We'll keep everything in atomic mass units and we'll be okay. And we want to assume the collision occurs in mostly empty space. So we want to find the velocities of both after the collision. So here's what we got. We got a proton moving with a velocity of, what did we say, 3.6 times 10 to the 4th. And its mass is 1.01 U. Got a helium atom here. The helium atom is at rest, so it has no initial velocity, and its mass is 4 U. And we want to find both of their velocities, so we want to find this after and this after. So I'm going to call this one 1 and this one 2, just because I had to pick. So let's find the final velocity of the proton. So I use this equation, v1 prime. M1 is this one, so it's 1.01 minus M2, which is 4, over M1 plus M2, so this plus this, so 5.01, multiplied by VI, which is this, 3.6 times 10 to the 4th. And I'm going to add to that 2 times M2, so 2 times 4 is 8, over M1 plus M2, 5.01 times V2, which is 0. So this is already eliminated because it's 0. So when I solve for this, that will tell me the final velocity of my proton, hopefully, right? So I calculate, I go 1.01 minus 4, and I divide that by 5.01, and then I multiply that by 3.6 E4, and I get, I'm going to put this in scientific notation, negative 2.15 times 10, I go 34 times 10 to the 4th meters per second. So the proton, negative velocity just means it bounces backwards. So I know the velocity of my proton. Okay, so that's the final velocity of my proton. Now for the final velocity of the helium atom. V2 prime, 2 times m1, so 2 times, so 2.02 over the two added together, 5.01, times the velocity of P, of the proton, times 10 to the 4th, plus, and since V2 is 0 as before, it's going to be plus 0. So 2.02 divided by 5.01 gives me this, and I multiply that by 3.6 e to the 4th, and I get a velocity of 1.45 times 10 to the 4th meters per second, and it's a positive answer. So they hit, they collide, the proton bounces back this much, and the helium goes with this velocity going in the positive direction. So again, elastic collisions, if we know it's elastic, these two are it, man. These two are it, and it's a pain in the butt to use, but it's better than having to go through some of the other ways.